Here we go, number 13, one of these solve each triangle problem. Notice they gave us 41, 64, I added that together, subtracted from 180, and I got 75. So we already found angle C, which is helpful, because now we can use the law of sine. Sine of 75 over 28 is sine of 41 over side B. That's what I've decided to do. Whoopsie. All right. Sine of 41 all over B. Now I'm going to chunk these out, do some work, get right back to you. All right, done a little work here. Looked that up, got 0.966. Looked that up, got 0.656. Cross multiply, got that. Cross multiply, got that. So now divide by 0.966. 0.966. And we're ready to go. 19.01. We'll just call it 19. Now, do not use Pythagorean theorem. We don't have a 90-degree angle. What can we do? Use the law of sine one more time. So give me a second. So what I did was I stole this information, 0.966 over 28, just stole it, and I went sine of 64 all over A. I'll do the work and get back to you. All right, so I set it all up, cross-multiplied, got 26.05. Let's just say it's 26. Call it good. Okay, easiest thing to do on this one is just to notice we got angle A missing, side A, but we got angle B and side B, so law of sine is our best friend. I wish they would have us practice a law of cosine here. Maybe we'll need it, but I can't see if we'll need it or not. So we're going to look this up. I'll do the math. Be right back. All right, so we did some law of sine, got down to here, recognized we need to find the angle. So we went second sine, or inverse sine, of 0.788. Calculator spits out 52. Notice we got two of the three angles. So we just add these together. We get 114. Subtract that from 180. We get 66 for that guy. And, once again, doesn't look like we need the law of sine, or cosine. So we're going to go sine of 66 degrees all over side C. And I'm just going to steal this one again, 0.833 all over 28. I'll get back with you in a second. Looked it up, and cross-multiplied, divided, 30.7. Let's go on to these matrices. Unit 9, finally. All right, these aren't too bad. So that says double everything in A. 4, -6, 2, 10, and then add it to B. Problem is, we would need a 2 by 2, something here, something here, something here, and we don't. So that is impossible. Okay, so this one, I've already rearranged it. I put B here, A here. I like to do that. I think doing it backwards is craziness. But we got row 1 through column 1. I'll explain things for this one. Goes in the upper left-hand corner. So -8 plus 1 is -7. Now I take that row, throw it through this column. So I get 12 plus 5 is 17. Keep it going. Go to this one. 8 plus 2 is 10. -12 plus 10 is -2. Now we go to this one. 6 plus -1 is 5. -9 minus 4 is -14. And that one is good to go. All right, next one is impossible. So they're saying multiply C by A. Here's C, here's A. 3 things in the first row, only 2 things in the first column of A. Can't do. Dimensions don't work. All right, inverse. Remember the formula. I'll give it to you in a second. So, if we have matrix A, your 2 by 2, which it is, it's A, B, C, D. So here's your formula. So we got to find the determinant of this. So that's 10 minus, always minus, -3. So that's 13. So I go 1 over 13, and now the little trickeration happens. We've got to switch A and D. So 5 and 2 get switched. And then opposite of B, opposite of C. So opposite of negative 3 is 3. Opposite of 1 is negative 1. And then we distribute this crazy 1/13 through. And we get 5/13, 3/13, negative 1/13, 2/13. And there's the inverse matrix. All right, so we're to letter E, find the determinant of C. Now we got a 3 by 3, and there's definitely a way to do it longhand. I just think in the world of an examination, you are probably going to be better off just putting your numbers in a calculator and getting her done. So let's just do that. So we're going to find our little matrix button there. So we got to go second matrix. We're going to edit it. And we're going to make sure we have a 3 by 3, which this one was already pre-programmed, but let's just act like it wasn't. Then we would go here and we would change our dimensions if we need to, but we don't. So then I'm just going to keep scrolling over, and now I'm going to change things. So I need a negative 4, and enter that, and 2, enter that, negative 6, enter that, negative 2, enter that, 0, enter that, on and on and on. All right, now it gets interesting. So we quit, which is kind of weird, but now we're going to have the calculator do a job for us. So we're going to go back to our matrices, and we're going to have it actually do something for us. We're going to have it find the determinant. So we're going to go 1. But now we want our list of matrices, which is the first one. I went back to matrices. I want the first one, so I enter it, and then it's just going to do the work for us. So negative 70 it is. Letter F is almost insulting. It's just saying take matrix B, multiply everything by 3. So just don't make a silly mistake. So negative 12, 3, 12, 6, 9, negative 3. Just triple everything. So number 15 is just a little abstract. You just have to hang tough. So it says find x, y. Well, here's x. Here's y. Just don't panic. There's first row, first column. So that's going to go in the upper left space right here. So 2 plus AB is going to go in the upper left. Now I got to put that through here, and that's going to go in the upper right. That's negative 6 plus AC. Sorry if this is getting a little messy. Now I got to do the same thing here through here. So that's negative 1 plus 5B. And then I get 3 plus 5C. And that's all they wanted. All right, my pre-calc B'ers, you're going to be mad at me, but maybe you're happy. Dr. Phil, I wish you would have figured this out for me, buddy. I know you figured this one out for me, but this one has a trick. So I just learned it like 2 seconds ago. So here we go. We got these coordinate points, and they build a triangle. Find the area. Distance formula, distance formula, distance formula. Then you got to go into the law of cosine, find it, and then use the area formula. Get ready. Crazy, crazy formula is we're going to build a 3 by 3 matrix using this point, that point, that point. And here's just, I don't know who discovered this, but it works, and it's crazy. So we start with 10, 2, and then we put a 1 here. We use this one, negative 2, 5, put a 1 here. We use this one, 1, negative 4, 1. Now, remember the formula 1/2 base times height? Somehow, it turns into being, this ends up being base times height, so we still need to take half. So we gotta take half of the determinant of this 3 by 3 matrix. Why does it work? There's a lot of things in math I just can't wrap my brain around. So, if we input all this information in our calculator, which I'm not going to take up time to do that, I'll do it right now and then I'll show you. So I didn't really show you the work or anything, but once I found the determinant of this by inputting it in my calculator. It ends up being 99. You just take half of that. And I am so sorry. Look how easy that was. But, you know, distance formula, distance formula, distance formula, law of cosine. That's good practice too, but I do apologize. All right, this time we are going to use the Dr. Phil. Dr. Phil, I will be forever indebted to you, my friend. So, find the area of the parallelogram. There's a very creative way you can do that. But this is an exam, dang it. So this creates the top row of our determinant, -1, 4, and this determines the bottom row. This is a lot easier than the previous problem because it's just a 2 by 2. So the area of a parallelogram defined by two vectors in component form, you can put them in a 2 by 2 matrix, find the determinant, -5 minus 8, and then you would get -13. But it is the absolute value of these if you end up getting a negative, so that would be 13. That would be the area of the parallelogram defined by these vectors. You could do it the long way, and you'll get 13, but we're going to take Dr. Phil's little helpful hint. Thank you, Dr. Phil. Okay, probably the last problem for this video. As you can see, we got to find x, y, and z. Kramer's rule should be lurking. We'll get this thing going here. I'll do it in little tiny chunks so I don't tear up this entire video time. So here we go. First thing we're going to do is rearrange it. I'll see you in 2 seconds. All right, so I recommend doing that. Get all your x's in a row, y's, z's, equals, and then your constants. Now I'm going to get ready to find the determinant. And I do that. And remember, x equals dx over d. We're going to start there, and then we'll talk. But I'm going to do this as fast as I can just to show you the little shortcut. All right, so as you can see, I found the determinant by taking all of the coefficients. I did not worry about these at all. I just chunked out all these coefficients and then put them here 3 by 3, put it in my calculator, and found the determinant to equal -73. Now how did I find dx? You take all these constants and you replace this column, and that's all you do. And these stay the same. And then you type this in your calculator, and these numbers turned out pretty nice because dx is -146. Now, that ends up being 2. Now, you could definitely find dy using the same strategy, but we're going to use our heads a little. I look at this one right here, and I think, you know what, that's the same thing as 3y plus 2z equals 14. I'm going to put this guy right in here. That's -8. So I'm going to add it to this side, and that's a -14. So if I take a -8 and I add it, I'm going to get -6. So that would be -5y plus z equals, what did I say? 8, -6. And now I'm going to use good old elimination. I'm going to multiply that by -2. I'm focusing on the z's. So I get 12 here. I get -2z here. And I get -10y here. And I'm going to add these together. I screwed up somewhere. These are supposed to be nice, neat, whole numbers. All right, that's what being in a hurry does. You guys probably picked up on it. This times this does not give me a -10, gives me a +10. So now if I add these together, these cancel, I get 13y equals 26, and y equals 2. So now that we know x is 2, y is 2, we can pick any one of these three. Well, this is the obvious, easy thing to do. We don't even need x. So y, we just found to be 2. So 3 times 2 is 6, plus 2z equals 14. We're going to subtract 6 from both sides, divide by 2, and we get 4. So our coordinate point would be 2, 2, 4. X is 2, y is 2, z is 4. And we're going to stop this video because we're going to start Unit 10 with the next video. So congratulations, we're moving along.